And welcome back. As we go ahead and continue looking at classes, we're now going to dive into looking at static methods. Now, we've actually already kind of seen these a little bit. We just may not be aware of them. So let's go ahead and take a look at that. So with static methods, we have seen these already. Particularly when we looked at the math class, we saw, of course, some examples of methods that didn't require us to create a calling object. We didn't have to say like a math object equals new math, right? We simply just said math dot, right? These are methods that typically do things, for example, in the math class, that do like simple numeric calculations, such as the maximum of two integers. Now, in Java, we can define a method so that we don't have to use a calling object. And when we do this, this is known as a static method. You define a static method the same way you would do any other method, except we're going to add the keyword static to the method heading. Now, what about actually invoking those static methods? Again, this is something that we've seen. Although a static method requires no calling object, it still belongs ultimately to some class, and that definition is normally inside that class definition. So, for example, when we have a static object or method that we want to invoke, we use the class name in place of a calling object. So we've seen this, for example, with the math class. We said math.pow base comma exponent. So this would be an example of me using that in the program. Another thing that we've seen is the exit method. This is actually, of course, something that we've used as well. This is another static method, and if you remember what it does, it pretty much forces the program to exit out. So if we want to end a program immediately, we invoke the static method exit, so system.exit0. Now note that with a static method, the class name serves the same purpose again as the calling object. So I didn't have to create a system class. Now, of course, we could create an object of the class system and use it to invoke the method exit. But this would be a little confusing, and sometimes having something like this is a lot simpler. So we a lot of times will say, hey, use the class name and then invoke the method. But remember, you can only do this if it is a static method. So with our static methods, within the actual definition of the static method, so when you actually look at the code inside, you cannot do anything that refers to a calling object, such as accessing an instance variable. So it's important to keep in mind because that means not every method is going to be able to become a static method. All right, and this is because the static method can be invoked without using a calling object, and because there's no calling object, there are no instance variables that are associated with it. The best way to think about this restriction is in the terms of the this parameter. So if you remember how the this parameter works, that kind of might give you a clue of how we handle some of this. So in a static method, we can't use the this parameter, for example, whether we're using it through an explicit call of using this dot or an implicit call where it's implied to be there. Now, there is a pitfall when we work with static methods, and that's invoking a non-static method with inside of a static method. So let's just say we have a method called myMethod, and it's a non-static method, and it's in some class. Then the definition of any method within the class would be of the following invocation. So myMethod, open close parentheses, means the same thing as saying like this dot myMethod. Now, it's important to know it's illegal to use a non-static method within the definition of a static method. However, it is legal to invoke a static method within the definition of another static method. So if you have a static method and you want to have that method call another method, it needs to be static. Now, what about actually invoking that non-static method? Well, there is kind of one way that we can invoke a non-static method within a static method. If you create a calling object of the class and use that object, rather than using the this parameter as your calling object, this is how you can accomplish this. So let's just say, again, myMethod is a non-static method within the class myClass. Then the following would be legal, myMethod. However, if we want that to be legal and not illegal, we want to say myClass an object equals new myClass, an object dot myMethod would then work. Because this, of course, right here, this method is, of course, going to refer to a static invocation. But this down here is doing more of a non-static invocation. So very important to note how we are using these here if you start dealing with that. Now, you're not always going to come across this because sometimes we're going to have static methods, sometimes we're going to have non-static methods. And you're going to just have to know, as a programmer, how do I handle these in their appropriate fashion? Now, one quick tip is that you can put a main, and we're referring to the main method, in any class. So up to this point, whenever we use a class in the main part of our program, the main method was by itself a different class definition within a file. So anytime we created a class, it was its own file, and then we had a main program that went and did all its things. However, sometimes it can make sense to have a main method within a regular class definition. So when we do this, it gives the class two purposes. It can be used to create objects of other classes, or it can also just run itself as a program. Now, Java has, of course, use for that term main. All right, whenever we see the main, that's our driver program, that's our testing program. Well, that's because Java has a requirement, first off, that main be static. If you look, it's public static void main string args. Thus, when we're within a main method, we can't actually use a non-static method of that same class, such as toString, unless we create an object of that class and then use it as a calling object for the non-static method. You don't want to place just any main method in class definition that's to be used as a regular class to create objects, like some of the ones that we've seen. We can't just necessarily just throw the main in there and call it a day. However, sometimes we want to do this because we want to do like small diagnostic programs. We're going to have our main method inside that class definition to help us with that. And so let's go ahead and take a comparison of what we're talking about here with some of the stuff, for example, with the main method. So here we have this program called roundStuff, and you can see all it does is calculate area and volume for a circle. And this is our demo, which of course is going to pull that information in. Now, one of the things you'll notice is that we are using this with a static invocation, because notice never do I call a roundStuff class here. I simply say roundStuff.area, roundStuff.volume. And that's because if I look at roundStuff, you'll see that this is a static method, and this is a static method. We also have a static variable here, but this, of course, gives us access to that. Now, of course, I could replace this out here and use math.py, but this is perfectly fine for the example we're trying to accomplish right now. And if we look at roundStuff2, all right, remember here we, of course, are having our main method right here. But if we look at roundStuff2, one thing you'll notice is we took everything that was in roundStuff and we simply just added that main method that was in roundStuff demo. And the reason why we can do this is because, again, we have these static methods. It makes it super easy for us to work with that. However, again, remember, this is a static method. If I took away the static modifier that exists here, or in this case for roundStuff2, exists here, we would run into some issues. We'd have to go and create a roundStuff or a roundStuff2 object. So I'd have to come here and say like roundStuff2, let's just say round equals new roundStuff2, open close parentheses, and you notice we don't have any errors, we don't have any issues. Where this could come in handy though is if I tried, let's say I had took the static modifier off here. Of course, we're going to get an error down here because now it's no longer static. But if I wanted to now change this so that way this was using this object, so I'll make this, instead of roundStuff2, call this round, and all of a sudden now this is going to work. So just little things like that to keep in mind as we start looking at the differences between, for example, static and non-static classes. Again, this right here is very important that these have to be static if they're static methods, because remember, this is a static method right here for the main.